Okay, so this video is on parallel vectors, and just the key word there in this video is parallel. What does parallel mean again? It just means when you've got two lines that never ever meet. So these two lines here, these are parallel because they never meet. If they went on forever and ever, they wouldn't touch each other. Okay, and because they were looking at parallel vectors, really we should draw on the fact that we've got direction here, so we could go and draw on something like this, right? These arrows are showing that the vectors, they're vectors, right? But most importantly, they're parallel because the lines never ever touch each other. Okay, right, this is important. Vectors are parallel if they are scalar multiples of each other. What does that really mean? A scalar multiple just means you're multiplying the vector by a number. Again, that won't make a lot of sense yet. Let's look at an example. So here, I've got vector A. Okay, so bold lowercase a is equal to 1, 3, written as a column vector. If I go and draw that onto a grid, which I've done here, so I've got my vector A down here, we're going 1 across up by 1, 2, 3. Or a scalar multiple just means you're multiplying, that's the key word there, your vector by some number. So if I go and take this vector down here, for example, I've got the vector 2 lots of A. So I've taken my vector A, which is 1, 3, and I've times it by 2. I've got 2 lots of 1, 3. 2 lots of 1, 3. And it kind of works out how you think it would work out. You do 2 lots of 1, which is 2, 2 times 3, which is 6. So the vector 2A is equal to 2, 6. If I go and draw this on my grid, there we go. So I'm going from here, because the arrow is going in this direction. So I start from here, I go 1, 2 across, up by 1, 2, 3, 4, 5, 6. But most importantly, right, what do you notice? You notice that the vectors are parallel. Okay, these two vectors, A and 2A, they're never going to meet. They're parallel. Okay, it's just this vector, 2A, is double, it's twice the size of vector A. Okay, so I've just multiplied the vector A by a number. That number in this case is 2. I've just doubled the vector. Okay, so they're parallel because they are scalar multiples of each other. So that's another key word that we can understand. Good, let's look at another one. So what about this one down here? I've now got minus 2 lots of A. So I've taken my vector A, I've times it by negative 2. That's my scalar multiple. That's my number I've times it by. Okay, so minus 2 lots of 1, 3. Well, minus 2 times by 1 is minus 2. Minus 2 times by 3 is minus 6. If I go and draw it onto my grid, and this time it is negative, so it's going in the opposite direction. I'm going from here down to here. I'm going across by 1, 2, down by 1, 2, 3, 4, 5, 6. If that's not making sense to you, watch my previous video on column vectors, this stuff up here. But most importantly, right, this video, parallel vectors, these vectors, they're all parallel, which you can see. They're never ever going to touch each other because they are scalar multiples of each other. That's really important. So I've just taken my vector A, I've times it by a number. The first green one, I've times it by 2. The red one, I've times it by minus 2. Okay, so vectors will be parallel if you take a scalar multiple. You're just timesing your vector by a number. Okay, hopefully that's given you a bit of a visual representation of what parallel vectors is all about. So let's look at some examples now of drawing some parallel vectors for ourselves. So it says shown on the grid is the vector B, written as a column vector 2 across minus 1 down. Let's just check that. I've got my vector B, I'm going 2 across and 1 down. That is correct. And it says draw the vectors below on the grid. So the first one is 2B. Okay, so let's go and write that out. So it is saying I've got two lots of the vector B. Well, the vector B is 2 across and minus 1 down. So we're just going to be doing 2 times by 2, which is 4. 2 by minus 1 is minus 2. Okay, it works out kind of how you think it would work out. So I'm going to go and draw in my vector 2B, 4 across, minus 2 down. Okay, let's go and choose a point to go from. Let's go for it could be any point on your grid. I'm going to go for here. We're going 1, 2, 3, 4 across, and then 2 down. So 1, 2. Okay, and my vector is going in this direction. You've got to make sure you draw that in. A vector's got magnitude, how long it is, okay, and direction, this spot here. Okay, and you've got to make sure you label the vector, which is 2B. So I've got 2 lots of my vector B. And again, they're written B in bold over here, okay, but we've talked about before previously that we can't write bold letters, so we write it B underlined. It means the same thing. But most importantly, right, these vectors, they are parallel. You can see these vectors, if they kept going, they would never ever touch each other. Okay, and the reason is, right, literally you just doubled that vector B. It's just twice as long, okay, but in the same direction. Good. Well, this one here, this one I've got minus B. So this time it's going to do it in a different color. That is going to be equal to, I've got the negative of the vector b. Well, the vector b again is just this, right? 2 minus 1. So times it by 2 minus 1. Or minus of that 2 is going to give me minus 2. And then minus times by that minus 1 will give me a plus 1. So plus 1 down here. Okay, so now we're reversing the direction of this vector b here. Let's go and draw it in on our grid. So let's choose a point. It could be any point. I'm going to go for this point here, because why not? This time I'm going across by 1, 2, and up by 1. Again, right, this part here, across, negative, we're going this way, up by 1, plus, up by 1. Good. And we're going to show the arrow. We're going in this direction, which is the opposite direction to the vector b. Okay, so there we go. And it's negative b, so vector minus b. Let's underline it. There we go. It's not very big, is it? Let's make it a little bit clearer. Minus b underlined. But again, you can see this vector is parallel to this vector, which is parallel to this vector. They're parallel because they are scalar multiples of each other, right? We're just timesing the vector b by 2 in the first case and by minus 1 in the second case. The final one, we've got the vector minus 3b. Okay, let's go and do this in a different color again. Let's go and do it in black. So that's going to be equal to minus 3 lots of our vector. Well, the vector b again is this part up here, 2 minus 1. So 2 and then negative 1. So 3 times 2 is equal to, minus 3 times 2 is minus 6. Minus 3 times by minus 1 is positive 3. So it's going to be going in the opposite direction to this vector, vector b, because it's negative. It's going to be 3 times as long as that vector. And I'm going to have to draw it over here somewhere, because I'm going to run out of room otherwise. Will I? Yeah, we'll do. So let's go and draw that over here. Let's go and start down here, because I'm going to run out of room. I'm going across by 1, 2, 3, 4, 5, 6, up by 3, 1, 2, 3. There we go. It looks a bit clumsy because I've kind of run out of room a little bit, but it works out. Okay, and the direction is here. Okay, because we started from this point here, across by minus 6, up by plus 3. That is my vector, minus 3b. So let's draw it in. So I've got minus 3b. There we go. Okay, but the key thing here is you can see all of these vectors, they are parallel because they are scalar multiples of each other. You're just taking the original vector, which is b, this one, and you're timesing it by the scalar multiples being 2, minus 1, and minus 3. Okay, all of these lines here, they're never ever going to meet. They're all parallel. And I believe that is it. That's our video on parallel vectors. Thank you for watching.